Hey, what's up? Welcome back. Patrick here from All Things Mathematics, and moving on to the next example. So here we are given this fairly large logarithmic equation, and we have to solve for the x value, right? So notice that we have the variable x here on the left side, and then we also have it on the right side. So what can we do here? Well, I'm noticing that both sides have this base of a over here, right? So maybe what we can do, because there's multiple logarithms on this right side, is we can combine it into one logarithm, right? Because we have one logarithm on this left side. We have log base a, 2x plus 3. And then if we can maybe combine everything on the right side to be one logarithm, like log base a, and then it's going to be some kind of expression in this bracket, well then we could just drop the log base a's, right? Because we'll know that this bracket and this bracket have to equal. So then we'll have 2x plus 3 is equal to whatever that expression is left over in that bracket, right? So first thing we have to do is combine this into one logarithm. Now, before we do that, notice that there are some coefficients here in front of these logarithms. So this 2 over 3 and this 1 over 2. Over here, there's no coefficient. There's like a minus 1. So first thing I'm going to do is I'm actually going to bring the coefficients up to the exponents, right? Because before we combine the logarithms, right, the logarithms have to be by themselves. There can't be any coefficients in front. There could only be like a 1, like imaginary 1s and negative 1s, right? Like the last one already has. So basically, I can rewrite this as log base a 27 to the power of 2 over 3 plus log base a 25 to the power of a half minus log base a 5x, like that. And then what I'm going to do, I'm going to take these expressions here, so like the 27 to the power of 2 over 3, and then what's that going to equal to? That's going to be some numerical value. You could plug it in your calculator. You could also do it manually if you want, like this, right? So this is 27 to the power of 1 over 3. I'm just splitting up the fraction. 27 to the power of 1 over 3 is 3. 3 squared, that's going to be 9. Right, so this here ends up being log base a 9, right? 27 to the power 2 over 3 is 9. And then 25 to the power of a half, well, that is just the square root of 25, right? That's going to be 5, like that, minus log base a 5x, right there. Now notice we have the logarithms with no coefficients in front, or there's just like 1s here in front. So now we can go into combining them, right? So these first two, notice that we have two logarithms that are adding, and just in general, if you're adding two logarithms, let's just say this is m and this is n. If you're adding two logarithms that have the same base, right, in this case they both have a base a, you could change that to be one logarithm, and you can multiply the expression. So I can rewrite this as log base a 9 times 5. That's basically 45, right? And then we still have this minus log base a 5x, like this. And then notice here we're subtracting two logarithms with the same base whenever that is happening. Let's write the rule down here on the side. Whenever that's happening, you could combine it into one logarithm, and you could be dividing, like that. So we can rewrite this as log base a 45 over that entire expression, 5x, like that. All right, and now notice we have that one logarithm on the right side, right? So we took this entire expression here and use logarithmic rules to write it as one logarithm on the right side. And so now, still on the left side, we still have this log base a 2x plus 3, but like I mentioned, we have log base a of something, log base a of something. That means that those two brackets have to equal. We could just drop the logs at this point, like that. And actually 45 over 5, that simplifies to 9, right? So this is like 9 over x here on the right side. So, So from here, I'm going to put the 2x plus 3 over 1, and then let's just cross multiply. So I'll have x times 2x plus 3 equals 1 times 9, like that. So this is going to be 2x squared plus 3x minus 9, like that, right? And then from here, you could throw this in the quadratic formula. I think this is going to factor smoothly because there are two numbers that multiply to negative 18 and add up to 3. That would be what? Positive 6 and negative 3. So we could factor this with decomposition like that. We could take out a 2x, x plus 3, take out a minus 3, that would be x plus 3. And so basically this is factoring into 2x minus 3, x plus 3, like that. And so then to get the x values, what we want to do is find out the x values that make each of these factors equal to 0. So this would be 3 over 2. There's 1, and then over here this is going to be negative 3. However, we got two solutions, but if you remember, whenever you got logarithmic equations, you want to take your solutions and plug them into the original one, because these two solutions are the solutions to this polynomial equation or this quadratic equation. It doesn't necessarily mean that they're going to be legitimate solutions for our original logarithmic equation. And the way we check that, if you remember, we plug in our solutions into any logarithms that have the variable. And remember, the brackets, they have to be positive always, right? Whenever you have log of any kind of expression, that expression always has to be positive, right? It can't be 0, can't be negative. So if you plug in your solutions into the original logarithmic equation for any of the expressions that have a logarithm and a variable, and you get either a 0 or a negative within the bracket, that's not going to be a legit solution. So notice 3 over 2, if I plug it in here, that's going to give me a positive value. If I plug in 3 over 2 here, that will also give me a positive value. So 3 over 2 is a legit solution. But notice if I plug in negative 3, this would give me a negative. This would also give me a negative. Only one of them have to give you a negative for it not to work. In this case, both of them give you a negative. So x equals negative 3, we would discard that as a solution. So the only solution to this logarithmic equation is x equals 3 over 2. And that is the end of the video. Hopefully you enjoyed that. If you want to find more videos like this, you can go to my website, allthingsmathematics.com. Over there, all my courses are organized for both high school and university. All the videos are organized by chapter. Also, if you have any questions, you can hit me up. My contact details are also on the website. Enjoy your day, and I'll catch you in the next one. Peace out.